Yo, what is up YouTube, and welcome back to the third video in this video series where I'm showing you from start to finish how to build a really robust multi-sig wallet application that runs entirely on the Ethereum blockchain. Yo guys, sorry for this quick cut. I just forgot to say in my intro that if you're new here, my name is Evan McGrain, and on Web3 Simplified, I teach you blockchain development. So if you're interested in that, I'd really appreciate if you could just take the time to hit the subscribe button and like this video, because it really helps out this channel with the YouTube algorithm for getting found. And also there's one other thing that I wanted to show you guys, and it's I've created a GitHub repository for this video series. So if I just switch my screen and we go into my repositories, I've created a GitHub repository. So after each video, I'm going to be uploading the code or the state of the project code at the end of that video. So what this will do is it will allow anyone who's watching this to jump into the project with me at any state of the process. So you can jump in at video 4 or video 3 and you'll be able to just clone this code and you'll be able to start typing straight away. So I'll leave a link for this GitHub repository in the description below, and the code for this video will be in the MultisigWallet 1 smart contract code and video 3. So thanks very much guys, and sorry, back to the video. So recall that in the last video, we continued the development of the multisig smart contract, and we implemented the transfer mechanism whereby we had the ability to create transfers, cancel transfers, and approve transfers acting as wallet owners. So in this video, we're going to continue on with the development of the smart contract, and we're going to be really upping the game here. So right now our wallet can only facilitate the transfer of Ethereum, but we want to implement it so that our wallet can facilitate the transfer of ERC20 tokens, because, you know, it's not really useful. Well, it is useful to have a wallet that can transfer Ether, but it's much more robust if we can transfer any token that exists on the Ethereum blockchain. So to do that, what we're going to do is we're going to use a special library of smart contracts called openzeppelin, and this openzeppelin library is all about making tokens and things like that, digital assets on the Ethereum blockchain. But there's one particular set of contracts that we're going to be focused on, and that is the ERC20 token standard library. And in this library, in the openzeppelin library, we'll be able to create our very own ERC20 tokens that we can then use in our multisig wallet to, you know, deposit, withdraw, and transfer, and all of that good stuff. So just before we actually jump into the code, I'm going to actually just go over what is the ERC20 token and why do we need it. So the ERC20 token comes from EIP20 token standard, which stands for the Ethereum Improvement Proposal, and 20 just means that it was the 20th one. So this token standard was actually the first token standard that was created or implemented for Ethereum. And today we have loads of different token standards such as ERC721, which is for NFTs, and a variety of others as well. But the ERC20 token standard was actually the first one, and it was a token standard for the transfer of fungible tokens on Ethereum. So a fungible token, you know, is just a token that you can have loads of different tokens and they're all sort of the same, whereas in NFTs, each token is different. They're non-fungible tokens. So we're concerned with the transfer of fungible tokens here, and this token standard here was authored by Vitalik Buterin and this Fabian, I'm not even going to try and pronounce that, in 2015, and it pretty much used or came up with a standard that should be implemented if you want to create a token or a digital token on the Ethereum blockchain. So there's a variety of different functions here that you know, we can use as part of this standard to create our very own unique tokens. So if we just go through them here before we actually get into the code, there's a few optional functions that we can include, but really these functions you should include, but they don't have to be. The first one is name, and this method can be used to give the name of our contract a particular token. So for example, if we look at Chainlink, its name is going to be Chainlink. Or if we look at the DAI token, its name is the DAI stablecoin. So that's what this function does, and then it returns a string of the name. The next function is symbol, and what this function does is, if you ever go into CoinMarketCap or CoinGecko, you'll see that a token such as Chainlink has its name, and then beside it, it will have a little abbreviated name, such as Link for Chainlink. And this is what the symbol is. So this function here returns the symbol of the token, which is just more of an abbreviated version of it. And this symbol is what we will use to identify the token on our wallet, for example, or if you're making a DEX, you'd use the symbol to identify it there. The next optional and the last optional function that we can implement is called the decimals, and this just sort of returns the granularity, or how many divisions your token has. So if you look at a dollar, you can split a dollar up into 100 cents. And this is pretty much what the decimals function does. So if we specify, it returns a uint, which will be how many decimals does our token have. If we specify 10, then the granularity of our token will be 1 by 10 zeros. So it's common to use the same granularity as Ether, which is 1 and 18 zeros. So that's probably what we're going to be using as well when we create our token. And then we have a function that just returns the total supply of the token, so we can set a total supply whenever we make it. We can get a function that returns the balance of the token for a particular address. And then these two functions are the most important. This function transfer allows us to transfer tokens from an owner who has a balance to someone else. And this delegated transfer function, or transfer from function, is probably the most important, and it will play a very big part in our wallet. So pretty much what this function does is it has 3 addresses. It has an owner, it has a spender, and then it has the actual ERC20 token that we want to transfer. And what this does is we can approve other people or other addresses to spend our tokens on our behalf, or to send our tokens to someone else on our behalf. So when we're using our multisig wallet, we will use this delegated transfer from function to approve our multisig smart contract to spend our tokens on our behalf. So that's what this function does. And then we have an approve function, which is required because in order for someone to be able to spend tokens on our behalf, we have to give them an allowance. They can't just spend all of our tokens. We have to say, okay, you can spend X amount of my tokens, and that's what we do with this approval function. And then we have a getter function called allowance, which we can just, put in any two addresses to see what the allowance is between those 2 addresses are, if there is an allowance. And then we just have events and a variety of events that we can fire. Now, these are some of the main function headings, but if we actually go into the openzeppelin library, which is an implementation of this ERC or EIP20 token standard, then we can actually go and look at the contract, because there is a few other functions that we will be using. So to get to it, you can go to github.com/openzeppelin /openzeppelin-contracts, or just Google openzeppelin GitHub, and you will get to this page. And we want to go into the contracts, we want to go into token, and we want to go into ERC20. So you can see there's a variety of other EIP token standards here, but we want to go into EIP20. And then here we can just go into the ERC20.sol, and actually we'll go into ERC20.sol, and you can see we have the name here, we have the symbol, we have the decimal, total supply, balance of, transfer, allowance, approve. We have the transfer from, and now here there's a variety of different other functions that we can call, such as increase allowance. If we want to, increase someone's allowance, it's pretty much self-explanatory. Or conversely, we can decrease the allowance. This is the transfer function, and then this function here is probably one of the most important. This function actually allows us to mint tokens, so we can declare the total supply of our ERC20 token. But once we declare the supply, we mightn't have the total supply being circulating. So what we can do is we can use this mint function whenever we want to actually mint these coins so that they can, be put into circulation so that people can transfer them, buy them, sell them, do whatever they want. And then we can also burn tokens as well. Here we just have an approve function, which we've seen. And then before token transfer, we won't really be using this, but we can just use this to execute some logic before we actually do a token transfer, and the same for after a token transfer. So that is the contract code. If you want to take a read, by all means do. It's very good to sort of understand exactly how this contract works in order to, to maximize is your ability to use it. But now that we have that done, let's just jump into the code, and we're going to start making our very own ERC20 token, and then we're going to implement it into our wallet so that our wallet has the ability to facilitate the transfer of EIP or of ERC20 tokens. Okay, so now that we've looked at the openzeppelin ERC20 contract, what we're going to do is we're now going to implement into our wallet the ability to not only transfer Ether, but any other ERC20 token, because we're going to make an add token function that's going to allow us to add any token that we want so that we can trade with it, so that we can deposit, withdraw, and transfer it. So what we're going to have to do this is we're going to make what's called a mock token. And how we're going to do that is we're going to create a contract that inherits this ERC20 openzeppelin contract, if you will, and we're just going to inherit that contract and create a token that we can use, or that we can implement in our wallet contract. So what we're going to do is we're going to create a new contract, because remember, all ERC20 tokens are smart contracts that run on the Ethereum blockchain that have their logic set up in such a way that they just mimic the characteristics and attributes of digital tokens. So we're going to come in here and we're going to make a token. Let's just call it link, because link is one of my favorite tokens. So link.sol. Oh, I put a hashtag in there by accident. Link.sol. And remember, whenever we create a contract, we need to declare the version of Solidity. So pragma Solidity. And I think we're using 0.8.7. That's 6.7. Let's just run that. Yep. And what we need to do is, in order to create this token following the, EIP 20 standard, is we're going to need to import the ERC20.sol contract from the openzeppelin library. So in order to do that, we just write import, and in double quotation marks in Remix, all you need to do is go to the actual contract file in the openzeppelin GitHub, copy the URL, and paste it in like this, and then boom, we have access to the contract and all of its functions. The way that we actually access the functions through our contract is we need to inherit it. So the way we do that is we just declare our contract, and we'll call it link. And to inherit in Solidity, we just say is, and then the name of the contract we want to inherit. So it's ERC20, and boom. And what we want to do is, to make the simplest token that we can, what we want to do is, when this contract gets deployed, so we're going to use a constructor, and when the contract gets deployed, we want to mint or credit the person who deployed the contract with a given amount of tokens. So what we're going to do is we're going to declare a constructor, and then what we're going to do is we're going to initialize this link token with its name and its symbol, because remember, the name and the symbol are the only two things that are required by the ERC20 contract. So we're going to say ERC20, which is the name of the contract, and we're going to pass in the name that we want to call our token. So I'm going to say chain link, and then the ticker or the symbol, which is just going to be link, all caps. And then in this constructor, we want to call the mint function, because we want to mint or create tokens for the deployer of this contract. And I just noticed I spelt contract wrong. There we go. And then, yes, we just want to mint. So remember, we called the mint function, which is given by _mint, and we want to mint message.sender. And I'm going to mint him the equivalent of 1 ether, which is 1 by 18 zeros, 1 and 18 zeros. So 1, and then I'm not going to count it on screen, but something like that is probably sufficient. And boom, that is all that we need to create a base ERC20 token. So congratulations, you've made your first cryptocurrency. It's as simple as that. There's one other thing that I want to do, and recall that if we want to allow people to spend tokens, we need to grant them an allowance so that they have the permission to actually, transfer tokens or do whatever they want. So I'm going to make a function called approve. And what we're going to do is we're going to pass in the address of the person that we want to approve to be able to use the tokens. So I'm just going to say owner. It doesn't matter. And we want to also pass in an argument for the amount that we wish to approve them. So we'll say amount. We'll call this public. And then what we're going to do is we're going to call the ERC20 approve function from the contract. So we'll say ERC20.approve. And then we're going to pass in message.sender. Or no, we're going to pass in the owner, sorry. And then we're going to pass in the amount that we wish to approve for them. And just like that, we have everything that we need for this token in order to implement it into our wallet. So now that we've created this token as a test, we're going to try and implement this into our wallet so that we're going to be able to deposit this link token, withdraw it, and transfer it. So what we need to do now is we need to figure out a way that will allow us to keep track of all of the ERC20 tokens that we implement into our wallet. So just like we did with the wallet owners, the easiest way to do that, to keep track of our tokens, is to create an array that stores all of the tokens that we added. And what we're going to do is we're going to keep track of the tokens by their symbol. And the symbol is a string. So we're going to make an array of strings. And I'm just going to call this token list. And this token list will allow us to, every time we add a token, we'll push the symbol of it into this token list, and then therefore we'll be able to keep track of all the tokens we have. So what we're going to do is in the constructor, because we can by default trade Ethereum, in the constructor, we want to push in the ether ticker into this token list. So we're going to say token list dot push, and we're going to push in ETH. So by default, we're able to transfer and play around with ETH. So now that we've done that, we actually need to make a data structure that allows us to keep track of the tokens that we have, such as the token address and the symbol of the actual token. So recall that when we made a transfer, we used a struct because transfers have more than one attributes. Well, tokens also have more than one attribute. They have an address and a symbol. So because that's the case, we're going to use a struct, and we're going to call this token. And our token is going to have two attributes. It's going to have a string, which is going to be the symbol, or I'm going to call it ticker in this case. And then we're also going to have an address, which is going to be the token address. And then what we're going to do is we need to make a mapping, which will allow us to map a certain ticker that we're passing into a function to a particular token address. So I'm going to make a mapping that maps a particular ticker, which is going to be a string, to this token struct that we've created. And this is going to be the token mapping. And you'll see why we'll need this now in a minute when we create the add token function. And then the only other thing that we have to do to adjust our mappings is, now that we have multiple tokens that our wallet can support, we need to be able to distinguish between the different balances that a wallet owner will have. So we need to make a nested mapping now. So I'm going to make a mapping from an address, which points to another mapping, which is going to point from a string, which is going to be the symbol of the token, to the actual balance, to the uint. So now then, when we call this balance mapping, what it's going to look like is it's going to look like balance of message.sender, for example, of the certain token. Let's say it's ETH. So this would give the balance of the user or the wallet owner for ETH, or then we could change it to link, and this will give us link balance. So that's why we need to make that double mapping. And the last thing that we need to do before we can actually create the functions that we need to implement the ERC20 tokens is we need to make another modifier. And this modifier is going to be called token exists. And pretty much we're going to use this modifier in all of the functions such as deposit, withdraw, and transfer, because when we say make a deposit, for example, we want to make sure that the ticker or the symbol that we're passing in actually belongs to a real token that exists. So what we're going to say is we're going to say string memory ticker, and we're going to say that require we want to require that we want to require that the token mapping of the ticker that we passed in, oh sorry, I forgot my square brackets. We want to require that the token mapping of the ticker that we pass into this modifier, and we want to require that the address of this token, so we'll say .token address, where's my token address, token address, and we want to require that this address is not equal to the 0 address or a null address. And if it is, we'll say token does not exist. So for example, if we were to include this mapping on our deposit function, for example, and we passed in a ticker of a token that didn't exist or that our wallet didn't support, then this modifier would throw an error and not let us to call the function because the token that we're trying to deposit actually doesn't exist. and then we implement this underscore just to tell us that, okay, if these requirements are met, then execute the function. And that is everything that we need now in order, well, for pre-processing, if you will. So now that we can actually create the logic that we need to implement the facilitation of ERC20 tokens. So we're going to actually make a function that allows us to add tokens. So I'm going to make a function called add token. We're going to pass in the ticker, and remember, when we're passing in strings into functions, we need to allocate memory, so we need this memory keyword. And we're also going to pass in the token address. So we're going to say token address, and I'm just using this little underscore here because the attribute of our token struct is called token address. So I just want to differentiate between those two. And we're going to make this public, and we're going to restrict it to only owners, and we're also going to restrict this token exists mapping, and then we're going to pass in the ticker that we have here. And then what we want to do is we want to make two requirements. We want to do two checks when we add a token. First of all, we want to make sure that the token we're adding already isn't an existing token that our wallet supports. So to do that, we need to loop through our token list. So we'll say for uint I equals 0, I is less than token list dot length. And then we want to increment our looping variable, so I++. And then we just want to say require that token list of I is not equal to the ticker. And then we'll say cannot add duplicate tokens. Boom. But you're going to notice something now. If I try to save this, right, we're going to get an error here. And if we read the error, it says not equal operator is not compatible with strings. So we can't compare strings in Solidity. So what we need to do is, if you're familiar with what a hash function is, a hash function takes a bit of arbitrary data and outputs that data into a fixed size output. So if we take the hash of some input, if the input remains the same, then the output hash is always going to be the same no matter what. So what we can do is we can take the hash of these two strings here and compare the hashes to see if they're equal. So in Solidity, we have a way that we can do this. It's called the KeyCac256 hashing algorithm. So if we take the KeyCac256 and then the bytes of this token list of I, and then do the same KeyCac256 and the bytes for this ticker, then we'll be effectively comparing the hashes of these two strings and comparing the hashes, which essentially is the same thing as comparing the strings themselves. So now if we save this, you'll see the error goes away. So that's just a bit of an annoyance, the way you can't compare strings. What I could have done is I could have said that the ticker is a bytes 32 and it would have gotten around that, but I just prefer to have it as a string. It's just a personal requirement. You can use bytes 32 by all means. So yeah, that's the first requirement. The second requirement is we want to see is the address that we're passing in. We want to see is the symbol of this address equal to the ticker that we're actually passing in. So that we just want to equivalate, is this token ticker actually equal to the ticker we're passing in? So we're going to say require that the KeyCac 256 of the bytes of the token, so ERC20, we need to call ERC20 so that we can access the symbol of this token address. So ERC20 of token address, where is it? Token address dot symbol. And then we want to compare, is this equal to the KeyCac 256 of the bytes of the ticker that we passed in. And I'm actually going to get an error because I forgot to import ERC20. So I'm going to import two things here. Sorry, I'm going to import the ERC20.sol, and then I'm also going to import the interface contract. The interface contract just defines all of the function headings, but doesn't define the bodies. So what this allows us to do is it allows us to, if we want to use a function, we can add our own logic on top of it. So we'll paste this in and then we'll add in IERC20. So if I save this, then this should work now. I have an error. Oh yeah, okay, I forgot to add a semicolon, and now this should work. Don't mind about them. That's just because we changed the balance. Yeah, so that works. So now that we've done these two requirements, we can actually initialize the token struct to create this token. So we're going to say token mapping of ticker, which is the symbol we're passing in, is equal to this token struct. We're going to initialize the token struct of the ticker and the token address. Token address here. And it's actually the underscore token address. And boom, that will allow us to initialize the token struct. And then all we have to do is we can say token list dot push, and then we'll push in the ticker so that now we have this wallet will support that, and we'll be able to you know, keep track of the tokens that we have. So if we save this, it's token list dot push, sorry. Then boom, that is the add token function fully complete. And there's one other thing we could do. We could actually emit an event called token added, and we'll just pass in added by, so we'll say message.sender. We'll pass in the ticker, and we'll pass in the address, so token address, and then we'll pass in block.timestamp. And then we'll just come up here and to our events, and we'll make an event called token added, and we'll pass in added address, added by, we'll pass in the string ticker, we'll pass in the address, token address, and then we'll pass in the uint time of creation or time of transaction. So if we save this now, that is our add token function fully complete. And now there's only two more things that we need to do. We need to modify this deposit and withdraw function, because remember that Ethereum is not a smart contract. The Ethereum coin doesn't have an address. So we can't just deposit, we just can't use this deposit function to deposit Ethereum in the exact same way that we're going to deposit the ERC20 tokens. We need to change up our method. So what we're going to do is I'm going to pass into this deposit function the ticker that we want to add, because what we could do is we could make another function called deposit ERC20 token. But if we have two deposit functions, then that's just going to cost more gas. So what I'm going to do is I'm going to modify this original deposit function to be able to transfer, or to be able to deposit both Ethereum or the ERC20 token, depending on what the ticker is that we're passing in. So if it's ETH, we're going to deposit ETH, and if the ticker is not ETH, then we're going to deposit the ERC20 token. So we need to add in this ticker, so string memory ticker, and then we also need to restrict this to token exists, and then we pass in the ticker like so. And then what we want to say is require that the balance of message.sender of ticker is greater or equal to 0, and we want to require that the balance of message.sender of the ticker yeah, okay, so what we want to say here is we want to come in here and we want to say if the keycac, if the hash of the ticker is equal to ETH, then we're going to update the balance by message.value. So that'd be equivalent to depositing Ethereum. So we'll say if the hash of the, sorry, come on, spell. So if the hash of the ticker is equal to the hash of ETH, like so, then we know that we're trying to deposit Ethereum. So in this if statement, we can just wrap this balance here, like so, and then we can emit this funds deposited event. So we'll grab this event and we'll emit it in here. And what we want to do is we're going to add in the ticker. So we're going to say ticker, and then we're just going to come up to this event here and funds deposited, and we'll say we want a string ticker argument. We're going to do this to all events, but I'm just going to do it one by one. And then what we're going to want to say is else we're going to say, we're going to do the deposit for the ERC20 token. And the way that we deposit ERC20 tokens is we use the transfer from function from the ERC20 .sol smart contract, because we want to transfer funds from the message.sender. Remember that when we deployed the Chainlink contract, we gave or deposited message.sender a lot of tokens, so he's going to have a balance. So we want to transfer the balance from message.sender into this smart contract. So the way we do that is we use the delegated transfer or the transfer from function. So the way we can do that is we can access the ERC20 interface. You can do it with ERC20 either, but I just prefer doing it with the interface. And what we can say is the ERC20 of the token mapping of the what address do we want to pass in? We actually need to pass in an address here as well. No, we don't. We can actually access, because the mapping maps the ticker and the address, we just need to pass in the ticker, and then we can call the token address like so. And then what we want to do is we want to transfer from message.sender, who has a balance, to address this. So we want to transfer tokens from a message.sender into this smart contract. So address this, and then we'll pass in the amount. So we're actually going to have to pass in an amount here, like so. And then let's see, does this work? It does, and I just forgot uint. Okay, now what do we have here? Did you mean ERC20? Sorry guys, I was wondering why this kept giving an error. It's because I didn't have the letter C in. So yeah, and then here I meant to say ETH, because we want to transfer ETH if we're in this case, like so. And if we do that, boom, then that gets rid of the error messages. And then we also want to emit an event in this else case here, where we and the ticker I want to pass in is we'll just pass it in as ETH here, because we know we're doing ETH, and then or else we want to pass in the ticker there, and then we just increment this deposit ID as normal, and boom, that is how we deposit or modify the deposit function to cater for the deposit of both Ethereum and the ERC20 tokens. So the next thing that we want to do is modify this withdrawal function. So we're going to do the same thing. We're going to pass in the string memory ticker, and we want to also require that the balance of the ticker, or we want to require that the balance of the wallet owner for the token that they're trying to withdraw is sufficient or greater than the amount. And then what we want to say is balance of, we want to reduce the balance. And then we want to say if, we can just copy this if statement up here. So we'll copy this if statement, and we'll come back down here, and we'll paste it in, and we'll get rid of these two because we don't need them. Then we'll do this, like so. Payable message.sender, that's the Ether version. So if the ticker that we're passing in is ETH, then just do this regular transfer. Else, we want to do the transfer function. Sorry, I'm used to Python as well with my semicolon. So else, then we just want to do the ERC20 version of the withdraw. So the way that we do that is we use the transfer function. So what we're going to do is we're going to transfer funds from the smart contract to message.sender. So what we're going to do is we're going to say ERC20, and we're going to use the token mapping again, and we're going to pass in the ticker of the token address. So we're going to transfer from this smart contract, or from the link smart contract, and then we're going to call that transfer. And we'll pass in, we want to transfer to message.sender, like so. And we want to transfer him the amount that we pass into the function that we want to withdraw. And if I save that, that's okay. And then we want to get this funds withdrawed event, and we want to paste it here. And we also want to paste it here. and then we add in ETH here. So we'll say ETH, and here we'll just say ticker, like so. And boom, that is this function. I have a mistake. Oh yeah, because we didn't add it in. So if we go to funds withdrawn and we add in the ticker, so it's a string ticker, like so. And if we save this, then we go down, then our withdraw and our deposit functions are completely done. So they might seem a little bit complex because this really is more complicated than what we were doing up till now, but I've done my best to try and explain it. So if I just go over it quickly again, if the ticker that we're passing in is Ethereum, then we just do a regular transfer. The way we know it's Ethereum is we compare the hash of the ticker with the hash of ETH. If it's the same, then we know we're dealing with ETH, and we just do a regular transfer or a regular deposit. This should be plus equals, and or else if the ticker is not equal to ETH, then we do this transfer from, where we transfer the funds from message.sender to the smart contract. So this will be equivalent to a deposit, and then likewise we transfer the funds from this smart contract to message.sender. Okay, so that is this whole modification of the contract done, and we can now facilitate the transfer and adding of ERC20 tokens to the wallet. So the only thing that we need to do is fix all these balance mappings. So let's just go through them one by one. Okay, so the first one is here. We're just going to say ticker, and we want to also pass in a string memory ticker. To make this quicker, I'm just going to copy this, and then we have another one here, so we'll say ticker, and then we also, yeah, so we want to also create a ticker in our transfer struct as well, because we want to know what token we're using. So we'll say string ticker, like so. Let's save this, see did they go away. Boom, they did. Actually, we want to create a ticker in the create transfer as well. So what I'm going to do is I'm actually just going to do all these now. So in the wallet owner added, we don't need it. Funds deposit, funds withdrawn. So we need string, or yeah, string ticker in all of these events. So string ticker. This is just sort of monotonous, boring work. So I'll be flying around, but you can do it yourself. It's not really that difficult. It's just making sure that you do everything and not leaving out something where you need a ticker. So we'll say string ticker, and I think that should be good. Oh, I have a mistake in deposit. Okay, maybe this should just be equals. Yeah, it should. Okay, so now the create transfer function is fine. Transfer requests. So yeah, it's just the ticker and the transfer cancels. So we pass in ticker here also. Does that get rid of both of them? It doesn't, because we don't have our string memory ticker in the function heading. And boom. And then we also have ticker here in this event. That should be that, and then we pass in a string memory ticker here, and we pass in the ticker here, and then we pass in the ticker to this event, and then that should be okay. What's wrong here? Ticker, undeclared identifier. Oh yeah, and then we pass in the ticker here also, and we have one more error. Receiver transfer, here we go, of ticker, and another error, and here we just say ticker. I think that should be it. We need to pass in the string memory ticker, and boom, that is this contract completely finished. So we now have the ability to not only transfer Ether, but we can use ERC20 tokens in our wallet. We can add any token we want and transfer, withdraw, and deposit it. So congratulations if you made it this far. This was no mean feat. This is a really cool contract now, and we're still not done. We're gonna even step it up another notch. So in this video you can really see what you're in for this wallet application. So really congratulations if you made it this far. I did move a little bit quicker in this video, but I hope that I've done my best to explain, and I hope that you guys understand. So the last thing that we're going to do is we're going to deploy the link mock token that we made and this new contract to see if all of the modifications that we made work how we want them to. Okay guys, so I just went ahead and did a quick test off screen because I spent a while testing the last time, and I don't want to spend so much time here testing and fixing mistakes. So I'd rather say I just find all the mistakes and go through them with you at once, just to make things quicker. So there was only a few little mistakes that I had, but pretty much the first one here is we shouldn't include the token exists modifier on the add token function because we haven't actually created the token yet. So therefore the token exists modifier is always going to revert, because if we haven't created a token, then its address is always going to be 0 until we actually are able to enter the token or enter the function and initialize the token. So we remove that here, and the way that we are not able to, like, our link contract, its ticker is link, but if we typed in LIN, then this would fail because LIN is not, or LIN that we pass in here is not equal to link, which is defined in the contract link here. So yeah, that's just something that we want to be careful of, not to add the token exist modifier onto the add token function. The second thing is in the deposit function. There was two things here, because we're at because ether doesn't have an address, then it's always going to fail the token exists modifier. So we're going to get rid of the token exists modifier here. And what we're going to do is we're going to copy the the exact requirement statement from the token exists modifier, and what we're going to do is we're going to paste it in only in this else statement here. So we don't want to even check this at all if we're depositing in ETH, but we do want to check it if we're depositing in an ERC20 token. And then the other thing that I did is here, I actually never I meant to do this in the withdraw function and the deposit function. So yeah, just sorry about that. I meant to put it into the deposit function first. But yeah, the other thing here is I wasn't incrementing the balance. So after this require statement, we should say balance of message.sender of ticker is is plus equals the amount. And then this one's all perfect. And then here we also want to remove, I actually never added it in, but we want to remove it, the token exists modifier as well, and then put the require statement only here when we're, in the case when we're withdrawing the ERC20 tokens. And then the last thing that the mistake I made was down here. I was able to approve, where is it? I was able to approve the transfer up until the limit was met, and the reason that this function was failing is because the transfer funds function had an error where we have to do an if statement here to see if we're transferring ETH or if we're transferring the ERC20 token. So what we want to say is if, actually I'm just going to copy the keycac if statement because it's the exact same. Where is it? So if keycac, so if the hash of the ticker is equal to the hash of ETH, then we know we're transferring ether. So we can get rid of this. And then we can pop in this. Oh, I didn't mean that. We can control C this and pop it in here. Like so. Else, the way we want to transfer the funds is we want, oh sorry, I didn't mean to do square brackets, curly brackets, there we go. So else what we want to do is we want to copy the ERC20 transfer from the withdraw function, because save me typing it out again. So where is my withdraw function? It is here. So we want to copy this, And the way we want to do the withdraw or the transfer, in the case where we're transferring an ERC20 token, is we want to transfer from the token address or the ticker that we're passing in, but we want to transfer from the token or the transfer requests. We want to transfer to the sender of the transaction. So we'll say transfer requests of ID dot sender, actually dot receiver, sorry, because we want to transfer to the person that we're sending it to, not to ourselves. And then the amount, how we access that is through the transfer requests of the ID dot amount, like so. And then we, oh, I have a mistake here. Expected primary oh, I already have a semicolon, so this should be okay now. And boom, then we want to emit our event, and boom. And up here, I actually emit an event in both if statements. So what I'm going to do is I'm just going to actually copy this event. There's no point in emitting it twice. We can actually just emit it with the ticker. So I'm going to emit this here and then delete this one because it's just a waste of gas. You could do it that way. It's more efficient to do it the other way. And then we'll do the same in the withdraw function where we get this and we just paste it here, fix my indent, and then delete this one here, and boom, that is it. So now let's test everything out. That compiles. So the testing's a bit complicated, but I'll explain it and it will be fine. So what we want to do is I'll delete both of them. So we'll delete the multisig, and we want to deploy the link contract and the multisig contract. So to deploy the link contract, we want to come in here. I want to go into the link file. I want to go into my link contract, save it, and then go back to deployment tab and deploy the link contract, and then switch to, or go back and save your multisig file. And then the multisig contract will show up here, switch to it, and then we want to deploy this. So now we have two contracts down here. We have link and we have the multisig. So what I want to do is I want to actually do a few things here. We want to, in order to be able to, for our multisig wallet to be able to, transfer tokens on our behalf, we have to approve our multisig wallet to have an allowance to be able to transfer the tokens on our behalf. So the way that we do that is we copy the address from our multisig wallet and we paste it in here. And then what we want to say is, I'm just going to get the balance just real quick. Oh, I deployed it as account. Sorry, I should have been in this account. Oh, what's going on here? There we go. I just want to grab this account so we can see that when we deployed the link contract, right, we are giving ourselves this much tokens. So I'm just going to copy this, and we want to approve our multisig contract to be able to spend, or to be able to facilitate the deposits, the withdrawals, and the transfers of all of these tokens. So we're going to give it an allowance by using the approve function. And then what we're going to do is we're going to open up this multisig, and we're going to add in two owners like we usually do. So I'll add in this address. Oh my god, my remix is really slow. Yeah, so we'll add in this address here. So we'll add wallet owner. He gets added in, lovely. And then we'll add in this guy here. And we'll add this guy in. Okay. And boom, now we have a sufficient amount of wallet owners. And what we can do now is, I'm not going to bother testing the ETH because Ether works. We already did that. We're only going to do the link just to keep this quick. So what we want to do now is we want to add a token. So let's try and add in this chain link token. So the way we can do it is we can get the address, because remember, to add a token, we need the ticker and the contract address. And let's try and add in something like XXX and then paste in the token address. If we try to add this, then you'll see that this reverts, because if we come up to the add token function, you'll see that in order for the token to be able to get added, then the ticker that we pass in must be equal to the symbol of the actual address So the ticker must be equal to the symbol in this chain link contract here, which is link. So that's the security feature that we add. So if we come back here, if we change this to link, then if we add it, then you'll notice that it gets added no problem. And if we get our token list, I never made a function to get the token list, but trust me, it will say ether and link. So now that we've added a token, let's try to deposit. So if we come in here now and we are in account for 0x4, so let's try and deposit, say, link, and we'll try and deposit, let's say, this much. I'm just going to throw in a load of zeros, and if we deposit this, then boom, you'll see that the deposit went successful. And if we go to our balance and we put in the link ticker, then you will see that we have a balance of whatever this is. It's nearly probably 2 ETH. And if we do the same, or if we copy this and we come into withdraw, we add in the ticker and we paste in this, and let's just do 1 and we withdraw. Then boom, it goes true. If we get our balance again, then you can see it goes down to 1. So everything's working perfectly. So the last thing to do is let's try and create a transfer. So if we create a transfer for link and we paste in this amount and we go and create a transfer, it doesn't work. Oh yeah, it didn't work, but not for the reason I wanted it to not work. We also need to get the receiver address that we want to transfer to. So I'm going to grab this account here because we know he's not a wallet owner. So we'll come back to this account and we will, where's my create transfer? We'll paste in the address we want to send it to, and then we'll grab this and we'll paste it in. And if we create a transfer, then nope, it won't go through because we have insufficient funds as highlighted here. So if we change it to 1 and then we, oh, sorry, wrong one. If we change it to 1 and we create the transfer, then boom, it goes through. And if we go to our transfer request, we can see we have a transfer request. We can also cancel this now. So if we come in and type in link and type in ID of 0, then boom, we can cancel it and the transfer request disappears. So I'm just going to deposit in more link because we have no more balance left. And then I'm going to create another transfer. Boom, we have the transfer request went through. Just to double check, there it is, ID 1 this time. So now if we try to switch to, say, this account and we approve the transfer, so we approve, or wrong contract. If we approve the transfer of link and ID of 1, and I just want to switch account, this one here, or did I switch? Yep. And then if we try to hit approve, then boom, it goes through. And if we get our transfer request, it goes out. And now let's switch into this account here and let's get his balance for link. And it's also 1 because I should have done it differently so that you could actually see the change. So yeah, why not? Let's make one more transfer. So we'll go quickly to this account here. What's our balance? Our balance is 1. So we'll create a transfer request to the same address, and then we'll quickly go up and we'll get this account. We'll approve this time ID 2. Boom. And then we'll quickly approve ID 2 again with this one. Boom, it goes through. Our balance should be gone down to 0. It is. And then if we go into 0xe, our balance should be 2. And yup, it is. So that is this contract completely finished. I hope really congratulations for making it this far, because it was not easy. This is quite a tough contract, especially if you're beginning. Well, it's not too difficult, but like, because there's not much DeFi stuff in it, but like for these like key cat things, if you're not used to all these hashing notations and all that type of stuff, it can be difficult if you're a beginner. So thank you very much for watching, and in the next video we're going to finish this contract by adding in the contract capabilities so that we can deploy multiple instances of this contract for a given user. So I just want to say thank you very much for watching, and I will see you guys in the next episode. So just one more thing, if you wouldn't mind smashing that like button and subscribing, just because it really helps this channel out with the YouTube algorithm, I'd really appreciate that. So take it easy guys, and see you in the next one.